So in solving the stoichiometry problems last time, we kind of gave the impression that if you have this much reactant of one thing and this much reactant of the other, everything is perfectly balanced. In reality, reactions aren't usually done that way. Usually one thing is in excess, and the other one is what's called the limiting reactant. It's the one that limits a reaction. We'll see what that is in a second. Just because it's easier just to have one substance that you measure very carefully, and the other substance, which is maybe not as convenient to measure, or it's just not as important because it doesn't cost a lot or whatever, then you just really are worrying about one substance. Okay, so to do a limiting reactant, you really are thinking about what happens when something gets completely used up. Okay, so limiting reactant is the reactant that when the reaction's finished, there's nothing of it left. Okay, and because there's nothing of it left, the reaction stops. Okay, you could not have a reaction unless you have both of the reactants, or if it's more than two, all of the reactants available. But if one of them is used up, the reaction stops. So because the reaction stops, the amount of product that you make is depending on how much of the limiting reactant you have, because you're not going to make any more after the reaction stops. So we call the other reactants, and it could be more than one, excess reactant, okay? Because it doesn't matter how much of it you have, but whatever it is, it's going to be left over. So completely used up, limiting reactant, excess reactant is the one that's left over. Okay, so we have to use this in order to figure out what's the maximum amount of product that we could possibly get. So the steps to doing a limiting reactant problem start off the same way as a regular stoichiometry problem. You have to have a balanced equation. There's no way of getting around having a balanced equation. We're going to use the same equation that we've used before, sodium going into water to make NaOH and hydrogen. It's balanced, okay? It's got the coefficients that make it balanced. And the information that you're given is that you have 4.5 grams of sodium reacting with 10 grams of water. Okay, so that's one of the keys to knowing that this is a limiting reactant problem. You're given two amounts. You're given two either masses or moles of the reactants. Okay, not two amounts, one reactant, one product, but actually there have to be two amounts of the reactants. And then you have to decide which one of these is going to run out first. Okay, so that is what the problem is. Which is the limiting reactant? The first step is you convert each one of these into an amount of one of the products, and it doesn't matter which product you choose. In this case, I have two. Sometimes it's easiest just to choose the one that's easiest to write because you don't have to write so much, or easiest to get the molar mass for. But I chose NaOH, and it doesn't matter which one I choose in order to answer this question, which is the limiting reactant. So I'm going to set up the same type of conversion that I usually set up for how much can I get if I start off with 4.5 grams of sodium. Okay? I am going to do the molar mass to convert it to moles, and I'm going to do a molar ratio to go from moles of sodium to moles of NaOH. Okay? When everything cancels out, I'm left with the moles of NaOH, which is what I want to know. I want to know how much product can I possibly make. So if I do this calculation, I see that I have 2 moles of NaOH. If I then do the second reactant the same exact way, instead of sodium, now I have water. Instead of the molar mass of sodium, I have the molar mass of water. Instead of a mole ratio that has NaOH and sodium, it's NaOH and water. Okay, and then I do all of the cancellation of units and put this into the calculator. This tells me that I have 0.55 moles of NaOH. Okay, which one of these do I choose? They can't both be right. What I choose is the one that, when one of these runs out, okay, I will not get any more product. And therefore, once I use up all my sodium, I will have 0.2 moles of NaOH, and I will never be able to get to 0.555 moles of NaOH. So it doesn't matter how much water I have, because I've already used up all of the sodium and I've only gotten this far. I will not be able to get this far. So the answer to which one is the limiting reactant is going to be always the limiting reactant produces the least amount of product. And in this case, it's going to be sodium. Okay, so that's the question, the answer to the question, what is the limiting reactant? You do not have to give a number for what the limiting reactant is. It's just asking which one of the reactants is the limiting reactant, and that's sodium. Same equation, same numbers, and now the question that goes a little bit further. What mass of NaOH can I get? Okay, so it's not just which is the limiting reactant, but now I want to know how much can I get of NaOH. I do exactly the same stoichiometry that I did for sodium. Okay, I don't have to do that stoichiometry for H2O because we already know that H2O does not determine how much NaOH is going to be made. It's left over after the reaction has already stopped. Okay, but instead of moles, because it's asking for mass, instead of moles of NaOH, I need to go one step further, do a molar mass. Okay, and that way I can convert moles to NaOH, and I can see that instead of moles of NaOH, I have 7.8 grams of NaOH. Okay, so that's how you go all the way through to how much of the product are you going to get. The amount of NaOH that you get is called the expected yield. That is the maximum that I could possibly expect out of this reaction with this amount of reactant. Okay? If the question is how much H2 can be made, the procedure is exactly the same. I'm going to start with 4.5 grams of Na. I am going to turn that into moles of Na. I am going to use a molar ratio to turn it into now moles of H2 instead of moles of NaOH, because now my unknown is H2. Okay? It is not moles of H2 that I want, but mass of H2. So I have to go the extra step of getting a molar mass. And now I have an answer that tells me I can get 0.2 grams of H2, and that is the expected yield of H2. This is the expected yield of NaOH. That's the maximum that I could possibly get for either one of these two reactants. So once again, we've come up with a step-by-step procedure that allows us to decide which is the limiting reactant, how much of the product could possibly be made, and which is the excess reactant. Very valuable for chemists to do.